let's talk about diodes. Okay, a diode is a device that allows current to flow in one direction and one direction only. Now, you can put a super high voltage and force it to go the other way, but you're going to have a come apart on the diode for the most part. Like, there is a certain amount of pressure that will force that diode usually to blow up. Okay, so the easiest way to represent a diode for understanding is imagine we've got this flap. Okay, so we've got this tube, and if we try to put water in this way, very little of it's going to come out this way. We're actually going to make it harder the harder we push, because that door only opens one direction, right? So a diode is just like a check valve. So if we put flow here, then what's going to happen is that door flap is going to open. If we put water going this way, it's going to push itself so that it's, not able to go anywhere. So this is the best analog for a diode that I can explain easily. Okay, so in electricity, what happens is, let's say we've got a bunch of negative charges over here, and we've got a bunch of positive charges over here. This is fairly simple. But what happens when you've got like charges? So we've got a positive charge on our source, and we've got positive charges right here. They're going to run away from each other, right? So what's going to happen to this gap is that positive charge is going to go towards the middle, and this negative charge, since they're trying to get away from each other, are going to squeeze that gap so that's smaller and smaller. Okay? So that's forward biasing. So what's going to happen is that gap is going to get really small, and it's going to get so small that electrons can start getting over it. Okay, this is forward bias. When we have the cathode connected to the negative part of the source, and the anode connected to the positive, we're going to get current through there. Okay? That gap gets really small because like charges repel. Alright, so if we have a diode and we've got our positive charges connected to our negative source, and our negative side connected to our positive source, what's going to happen? Those are going to be attracted to there, so that gap is going to get bigger, and current will not be able to flow. Okay? So if our anode is connected to our negative, and our cathode is connected to our positive, you're not going to get flow. How does that look on a schematic? If it's got a diode to it, there's a bunch of different diodes. One of them will have some squiggly lines showing that light is emitted. That's a light emitting diode. It can only let current go in one direction, so it'll light up when it's going in the right direction. It won't light up when it's going in the wrong, or trying to go in the wrong direction. This line right here represents the side that our cathode is on. Okay? The other side is going to be our anode. Alright, so after watching this video, if I have these two diodes, 1 and 2, which one will conduct and which one will not? So we're going to put this as a question in the quiz. And the neat thing is, I'm not telling you the answer. You're going to have to infer the answer. Okay? Alright. So, well, let's do one more. Alright. What could we use diodes for? A lot of times we'll have an alternating current source. Like when we plug into the wall, what's happening is the current is going this way for a little bit, and then it's going this way for a little bit. But a lot of our devices need a DC, power supply. So what we can do is we can rectify it. Okay, so imagine, let's just imagine that I put two diodes like this. When this is going clockwise, it's conducting through this diode. But then it can't go through this one. Alright? When we're going this direction, let's say it's pushing out, but nothing's going through here. So we're taking that back and forth, and all we're doing is we're pushing and stopping, and then pushing and stopping, and then pushing and stopping. But as long as this is over 0 volts, we never pull anymore. Okay? We just push, and then push, and then push, and then push. So for your lab, I want you to make this. Okay? Like on a previous module, I showed you where to get the diodes from. Like, we look up here, and this little center one right here is a diode. Okay? We can put that in the circuit. Go to down. Alright, so we're going to say 10 hertz. Alright, so when you put your, you haven't had to use this yet. Instead of using a DC power source like we've used the second one, use the first one with the sine wave. Now that we've got a sine wave, we can change like the voltage out and the frequency. Put it on 10 hertz. Okay? Set up a 1K resistor and 4 diodes set up this way. It is not going to work unless you do it just right. And then get it running. Okay? And pay attention to what goes on. When we have a negative part of the sine wave, 1/2 of it's conducting. When we have the positive going, the other half is conducting. And basically what we're doing is we're taking that sine wave, and for every negative going half wave of that, we're flipping it up. So look at the blue. The blue is going above. You just can't see it because the green is covering it, but it's there. But every time it goes under 0, instead of starting to pull, it keeps pushing. So if you look at what's going on that load, that resistor is representing our load, it's always going in one direction. So it is DC. Now it's not going in one direction real smooth, but it never goes across that 0 point. So it's never pulling. And later on what we can do is we can beef this up a little bit by putting some capacitors so that once it gets over a certain point, it'll start charging that capacitor. And then once it starts getting below a certain point, that capacitor will discharge and start smoothing out that green line, so we don't have, that big old V there. Like if you have that big old V there, it's DC, but it's real noisy. And you're going to get, if it's from the wall 60 hertz, it's going to be a 120 hertz circuit, signal right there, because it's, going twice every time we go once, right? So we can use capacitors to make that green line start straightening out. And we'll learn that later. But this is what I want you to build. I want you to take a screenshot of it. And I also want you to do a little video seeing if you can put into your own words what's going on through this lab. Hope y'all have a good one. Looking forward to seeing you. Bye.